Have you ever built something absolutely amazing in a program, maybe a game or an app, only to watch it vanish forever the second you close it? Well, in this explainer, we are going to tackle that exact problem. We're talking about how to make your digital ideas permanent.
Let's start with a feeling I think we've all had. You know, you just absolutely crushed your high score, you're feeling on top of the world, and then, boom, the power flickers or you accidentally close the program. And just like that, it's gone. It is so frustrating, right?
And this happens everywhere. Think about it. Your hard-earned Minecraft scores, just poof, gone after you log out. Or maybe you're in Roblox at a virtual concert. You vote for your favorite artist, and a minute later, it's like it never happened. It's the sports tracker that forgets your morning run, or the playlist app that can't remember a single one of the awesome songs you just added. Now, this isn't a bug. It's just how programs work by default until you tell them how to remember.
And that, right there, brings us to our first section, what I call the disappearing data problem. This is the fundamental challenge we've got to solve if we want to build anything that lasts.
So here's the absolute key. By default, a program's memory is temporary. It's kind of like a short-term memory or like a conversation. Once it's over, the words just fade away. Unless you write them down. And in the world of programming, writing things down means using files.
Which conveniently leads us right to the solution. Let's get into Section 2, Saving Your Progress with Files. This is how we give our programs a real, long-term memory.
In Python, and honestly in most coding languages, it really just boils down to these three simple steps. First, you open the file you want to work with. Second, you either read data from it or you write new data to it. And third, and this part is super important, you close it. Closing the file is what actually saves the changes and lets other programs use it. So it's just open, act, close. Simple.
Okay, so when you open a file, you have to tell the computer what you're planning to do. You have to pick a mode. So R is for read, you're just looking, not touching. Now W is for write, and you got to be careful with this one. It will completely erase everything that was already in the file. But then there's A for append. Append is your friend. It just adds your new stuff to the very end of the file, leaving all the old data perfectly safe.
And hey, you want a pro tip? Forgetting to close a file can cause a ton of headaches and weird bugs. That's why modern Python gives us this awesome structure, with open ... When you use this, Python guarantees that the file will be closed for you, automatically, even if your code breaks halfway through. It's just the safest, cleanest way to handle files, period.
Let's see how it looks in the real world. Here, we're opening a file in write mode, that's the W, and then we write the player's name, their level, and their score. See that /own at the end of each line? You can think of that as the code for press the enter key. It makes sure every piece of info gets its own nice clean line in the text file. Now let's flip it. What if we want to read a file, like a K-pop playlist? This time we open it in read mode, the R. Then we can just loop through every single line in the file and print it out. That little .strip command at the end? Oh, that's super useful. It automatically cleans up any invisible junk, like extra spaces or blank lines, so our output looks perfect. Okay, let's go back to that append mode. This is really important. So here is our Minecraft leaderboard before a new player comes along. Right now, it's just Steve and Alex holding down the top spots. And now a new champion arrives, Creeper Slayer. We open the file in append mode, that's the A, and write their new high score. And look, Steve and Alex are still there. Append just added the new score right to the end. Now, think about it. If we had used W for write mode, Steve and Alex would have been totally erased. Creeper Slayer would be all alone. That's the difference, and it's a big one.
So, let's do a quick recap. These are the key things to burn into your brain. First, always use with open. It's just safer. Second, when you write to a file, remember to add that /n to make a new line. Third, when you read from a file, use .strip to clean up the data. And finally, a for loop is absolutely your best friend for reading through a whole file.
Okay, so we've totally solved our data saving problem, but to build really cool stuff, we need to understand a few more core ideas. Let's think of these as the universal Lego blocks that make all modern software work, from a simple text file to a massive online game. First up, variables versus constants. A variable is just a label for a value that can, vary. A player's score is a perfect example. It's always changing. A constant, on the other hand, is for a value that is totally fixed. It never, ever changes. The value of pi is a classic example. You set it once, and it's locked in stone. Knowing when to use which is a huge part of writing stable, predictable code.
All right, so we've got our data stored in variables. But what happens when you have a lot of data? Like a whole list of high scores, or a playlist with hundreds of songs?
We need a good way to keep all that information organized.
And that's where the array comes to the rescue. An array is really just a fancy word for an ordered list. It's a container that holds a bunch of items, one after the other in a specific sequence. And the way we find anything in that sequence is by its position, which in programming we call an index.
Now, get ready for the first big aha moment, or maybe, wait, what moment, for every new programmer. How computers count. See, for us, the first item in a list is number 1. But in code, the first item is at position 0, index 0. So if you look at this array of scores, to get that first score, 85, you'd ask for scores 0. To get the third score, the 92, you ask for scores 2. Getting your head around this counting from 0 thing is a massive step forward.
All right, we can store data. We can organize it. But what about the actions we want to perform, like the code to save a score? We don't want to type that out every single time a player gets a new score. That brings us to our final, super powerful building block, making our code reusable.
We do this with something called a subroutine, or what you'll more commonly hear today, a function. All it is a chunk of code that does one specific job, and you give it a name. For instance, you could create a function called saveScore. Now, instead of rewriting all those file handling steps every time, you just call your saveScore function. You write the code once, and you can use it 1,000 times.
And the benefits here are just enormous. You get reusability, which saves a ton of time. You get modularity, which means you can take a giant, scary problem and break it down into small, easy-to-solve pieces. This makes your code so much easier for you and others to read and fix. And it's absolutely essential for teamwork. It lets different people work on different functions all at the same time without stepping on each other's toes.
And just like that, look how far we've come. We started with a simple, really annoying problem, losing a high score. But by figuring out how to solve that one little thing, we've actually uncovered the core logic, the fundamental principles that are used to build every single complex program, game, and website you use every day. It's all about storing data, organizing it, and making reusable chunks of logic.
So where does that leave us? Well, you now understand the essential building blocks of creation. You have the tools to make your ideas real and permanent. The only question left is, what are you going to build first?